Alright, what we're going to be looking at today is going to be dealing with solving quadratics using the quadratic formula. But we're going to look at a problem that we did in the last lesson, and this was solving this quadratic algebraically. We have several different ways that we can do this. We can do it by undoing the radical. We can do it by factoring. We can work backwards. But the best thing to do is to use Desmos. Because on Desmos, once I type this equation in, we are looking at where does the graph cross the x-axis. We find that the graph crosses the x-axis at 2 points at -7 and 3. So if you're given a problem, I would recommend that you, first of all, type it into Desmos, especially if it is multiple choice. Alright, we're looking at the quadratic equation ax squared plus bx plus c equals 0, where a is the coefficient of x squared, the quadratic term, b is the coefficient of x, the linear term, and c is the constant term. The quadratic formula is x equal -b plus or minus the square root of b squared minus 4ac over 2a. And the highlighted part inside the radical is called the discriminant. The discriminant tells us the number of solutions and the type of solutions that we would have. So if you were to determine what the value of the discriminant is, if the value is greater than 0, that means it is positive, you're going to have 2 real solutions, which would mean that your graph is going to cross the x-axis at 2 points. If the discriminant is equal to 0, it is going to have 1 real solution, and it will only cross the x-axis at 1 point. If the discriminant is less than 0, that means that it is negative, and you're going to be taking the square root of a negative number. It is going to have no real solutions, which means that the graph does not cross the x-axis at any point, and the solutions are imaginary. All right, we're going to look at this problem which we're solving using the quadratic formula. The first thing that I did was to find the value of the discriminant, and when I did that, always make sure when you square the b that you put the number that you're squaring in parentheses. I simplify this and I get an answer of 8. That tells me that I'm going to have 2 real solutions. So I'm plugging into my quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac over 2a. I have the value of b is 8 because b is the number in front of the linear term x. So I would have -8 plus or minus the square root of the discriminant, 8, over 2 times 2, which would give me 4. I'm going to break 8 down as the square root of 4 times the square root of 2. Simplify, and I get -8 plus or minus 2 times the square root of 2 over 4. The last thing that we're going to do is we're going to divide each part of the numerator. So I'm going to take the -8 and divide by 4, and I'm going to take the 2 times the square root of 2 and divide by 4. And when I do that, I'm going to end up getting -2 plus or minus the square root of 2 over 2. All right, this one asks, what is the discriminant and how many solutions would the quadratic have? In order to do this, the first thing you always want to check is that your equation is equal to 0, which it is. Once it is equal to 0, you are going to plug into the discriminant. The value of b in this case is -6, so I would have -6 in parentheses squared. When you type that into Desmos, always make sure that number is in parentheses. Minus 4 times a A is the coefficient of the quadratic term x squared times c, and c is the constant term. When I simplify this, this gives me 36 minus 36, which has a value of 0. Therefore, I know it has one solution. All right, on this one, we're finding the discriminant. You're given the equation in the form of y is equal to, and that's perfectly okay. This is the same thing as 8x squared minus 6x plus 1 is equal to 0. You're going to plug into the discriminant. Your b value is negative 6, so you have negative 6 squared minus 4 times a, which is 8, times c, which is 1. Simplify, you're going to get 36 minus 32, which has a value of 4. Okay, and because this is 4, even though it does not ask, we know that there are going to be two real solutions. All right, what is the discriminant for this quadratic? Notice when you look at the original problem that it is not equal to 0, nor is it equal to y. Therefore, you have to make that right-hand side equal to 0. So in order to do that, to get rid of 7x, I would subtract 7x from both sides, which I did. To get rid of minus 1, I would add 1 to both sides. Okay, I just did that in the same step. If you need to do it in individual steps, that's perfectly okay. That gives me the quadratic equation, 3x squared minus 4x plus 2 equals 0. I have a value of a is 3, b is negative 4, and c is 2. So I plug into the discriminant. I have negative 4 squared minus 4 times a, which is 3, times c, which is 2, and that is going to give me 16 minus 24, and that has a value of negative 8. I know then that there are no real solutions, which means that my answer is going to be an imaginary solution. 4x squared plus 12x All right, we're finding the discriminant for this particular quadratic. It is not equal to 0, so I'm going to make it equal to 0 by adding 12x to both sides. The left-hand side becomes 0. The right-hand side, I always want to make sure that my quadratic equation is in the proper order, in standard form. So I put the 12x in the middle, and it would be plus 9. I find the discriminant, which is going to be b squared minus 4ac. A is 4, b is 12, c is 9, and I plug that in to get 144 minus 144, which has a value of 0, which means that there is going to be one real solution. right, on this last one, we're solving the quadratic equation 5x squared plus 2x equals 1. We're going to subtract 1 from both sides, and my equation becomes 5x squared plus 2x minus 1 equals 0. My a value is 5, my b is 2, and my c is negative 1. So I find the discriminant. I'm going to have 2 squared minus 4 times 5 times negative 1, which is going to give me 4 plus 20, which is 24, which tells me there's going to be 2 real solutions. Okay, 2 real solutions doesn't mean it has to be an integer. It could be actually containing a radical. So I plug into the quadratic formula, and I would have negative 2 plus or minus the square root of 24 over 2 times 5. I break 24 down as the square root of 4 times the square root of 6. Simplify, I get negative 2 plus or minus 2 times the square root of 6 over 10. Divide each part of the numerator by 10, and this simplifies to be x equal negative 1 over 5 plus or minus the square root of 6 over 5. Therefore, there are 2 solutions. You have x is equal to negative 1 over 5 plus the square root of 6 over 5. And you also have the solution x equals negative 1 over 5 minus the square root of 6 over 5.